So this AMPACE company reached out to me and asked me if I'd promote one of their portable power generator off-grid power station things. And I said, heck yeah, because I am working on, well, come this springtime, I'll be working on an off-grid treehouse. And inside of this treehouse is all kinds of 90s tech. It's going to have like CRT TVs and Nintendos and other TVs, radios, whatever. You get the idea. If you want to see more of that, you'll just have to subscribe because I'm waiting until springtime. Here in the Midwest right now in December, the weather is awful. It's gray, it's cold, and this is solar chargeable. And I'm not going to be doing any solar charging with this right now because it's miserable outside. But it's going to be great for this project I'm working on. Anyways, but here on this channel, I take stuff apart. I'm going to see if this thing is really as good as the marketing says it is. It's supposed to be good for 600 watts. So we're going to test that. The battery capacity is supposed to be 580 some odd watt hours. We're going to check out the battery. I don't know if the company that sent this knows that or not, but yeah, this thing's coming apart. All right. If you can make it all the way to the end of the video, I will be giving away some stuff. Coet sent me a care package of some new products. At least I think this is new. I don't know. Here's one of their multimeters. I'm going to take this out and actually use this to test this. And here's a wire stripper that I'll also be giving away. All the giveaway details will be at the end of the video. Back to this. This thing right now is on Amazon for about 400 bucks. Which is actually pretty reasonable for one of these because lots of batteries are expensive. Even if you look at like e-bike batteries, anytime you have a ton of 18650s or a lot of battery, it gets kind of expensive. So 400 could be a good deal if it is what they say it is. Yeah, it's all in English. All right, whatever. I don't think I'll be needing. Oh, I do recognize that though. This thing is also supposed to be able to jump start a car, so I'm guessing the battery is set up for 12 volts, so it'd be, let's see here. So if this is set up for 3S, it would be a 12.6 volt main battery pack. If it's set up in 4S, it'd be 16.8. So it's either probably 3 or 4S main battery, and they just use that to have DC come straight out to the car jump pack, which is kind of cool. I kind of like that they added that. So if you're need an emergency jump start and you got this with you, say you're out camping and leave your ignition on accidentally and kill your battery, you'll be able to get yourself jump start. Okay, let's see what's in here. This one feels pretty light. Oh, just AC cord. Is that a figure 8? Yeah. Standard figure 8 AC cord and a barrel plug cigarette lighter adapter. We'll see what that is for some point in this video. And this is the AC charger. So okay, so yeah, the figure 8 is just for the AC adapter. So you can charge this on just a regular wall outlet, or you're supposed to be able to charge it by solar, which that is how I will be doing it later in the year. There it is. All right, so let's get in closer and see what we got. Looks like the shell, I didn't need that anyways. Plastic here. Looks like, what we got down in here? Some fans maybe? Just some vent holes there. That's plastic. Bottom's plastic. So it's a plastic shell. All right, handle feels good though. The handle feels like that might even have metal inside of it, maybe? Or is it just actually a solid plastic? Anyways, construction feels fine for what it is. It feels strong enough for its weight. It's got a little bit of heft to it. So let's see what we got for ins and outs. We'll start at the top. Here we got an LED light. What do I got here? Okay, so there's on. Oh, battery says 82%. 2 watts. So that must be what we're using 2 watts. A watt meter built in. That's nice. Oh, that's even brighter. Still says 2 watts. Ooh, 10 watts on bright mode. Oh, and there's your seizure mode. And there's dance mode. Nope, wait, that's SOS. Yeah, it's got a pattern to it. Anyways, and there's off. Okay, so I see each set of outputs has its own switch. Oh, it even tells you the time left. So I suppose the current draw, which is 0, we have 99 hours left, which is probably the maximum that meter goes up to. Oh, the display is kind of cut off a little bit there. Oh no, if you look down, you can see it. If you look like that, it's cut off. Anyways, so yeah, each section of outputs has its own on-off switch, and I'm sure that's to conserve as much power as possible. Let's see what happens when we turn on AC. Ooh, we got some fans that just turned on. Oh, and back off again. So thankfully those are only come on as needed. Okay, and here is the jump start. So there's the plug, which it didn't come with the jumper cables, but I have some other jump packs that use the same plug. An extended battery, so I guess you can give it more battery capacity. And input, and there it's labeled. See if I can see that without the glare. 12 to 30 volts, so that would be solar, a good solar panel range, and then also this AC adapter. Let's see if the AC adapter goes right in there. Yeah, so you charge it. So I guess it doesn't care if it's getting charged through an AC adapter or solar panels as long as it's within the range. And the cigarette lighter plug, yeah, this barrel plug looks like it fits here too. Okay, yeah, so you can just charge it off of your cigarette lighter too if you need to charge it on the go. I think I'm ready to take this thing apart. So let's do that. So Kuwait sent along one of their precision screwdriver kits. I've already checked this kit out. Sorry guys, I'm not giving this one away because I think I'm gonna keep this one for myself. But of course there'll be links below if you want to buy one for yourself. But this has a nice assortment of bits, and I think I saw some that might even work on Nintendo, which is kind of nice, so you don't have to buy a separate kit. Anyways, I think this one here looks about right. Yeah. Ooh. Stuff. There's the fans. All right, many layers of stuff. So I can see the battery down in there. I'm gonna see if I can get. Ooh, here we go. Here we go. Let's take a look at the back. Oh, there's aluminum rails. Nice touch. So there is the battery. I still can't really see much. Guess I gotta keep on going. All right, so I got the front panel off. It's kind of built in a modular way. Everything just kind of slides into the rails, which is nice. Now the DC side looks nice. It's got 8-gauge wire going to the jump ports and the extended battery ports, so that looks good. But these AC wires here, so here's the AC outlets, and here is the wire that runs those outlets. And the gauge is printed on the wire. Let me see if I can find it again. Might be hard to pick up on camera, but this is 20-gauge wire. It's a little concerning. It's not grounded, but it's the power bank. There's, it's a plastic chassis power bank, so I can see why there's no ground being used, but that's not concerning. What is concerning is this gauge of wire is awfully thin. Now, you got to keep in mind, it's only rated for 600 watts, which is like half of your typical outlet rating. So there's not a ton of power going through here, but it is a little concerning to see that thin a wire used. 20-gauge wire can handle maybe up to about 5 amps before things get sketchy. That's if it's a good rated wire, it can handle 5 amps. So 5 amps at 120 volts is 600 watts. So it's like they're right on the edge of what this wire can handle. Boy, I mean, technically it's enough. So there you can see it is not copper wire, it's aluminum wire, which is kind of not helping its situation on the 20 gauge. Again, technically it's enough, it's just right on the border. Anyways, let's march forward. I'll mess with that later. So I got down to the battery, BMS board, the balance board. Just about down to the battery. I got the little cage out of the way that goes over the top of the battery. Construction wise, it's looking good. I mean, there's a metal plate on the bottom, and that metal is attached to these aluminum rails, so it has a metal skeleton inside of it. So it's like, some of it's really impressive. Like, this part looks good. So it's not like completely sketchy. I don't know, this company will probably never send me anything again. But, oh well. I want to get to this battery and see what it is. And here is what the bottom looks like with everything removed. So there's your metal plate attached to the corner posts. And I just about have the cells exposed. So here we have the balance, the main positive, the main negative. There is a number on the side here. Let's see if I can get that in view in case anybody wants to look it up. Come on, focus, phone. Is that in focus? Anyways, it's got a model number, but no specifics on voltage or current or capacity, I mean. But I think I can just unclip these and get to the cells themselves. It does look like it is probably just rows of 18650s. Yep, they glued it. I'm not getting any gap here in this seam. They glued it. There's really no access hole or anything to get in there. So we'll just have to make assumptions with the information we can get to. Now let's take a closer look at this battery. While unfortunately I can't crack it open because the seams are sealed, there is some other clues we can go off of to see what this really is. First, let's take a look at the Amazon ad. In several areas, it claims it's lithium iron phosphate. It's right there in the title. It's down in the about this item. There is a lithium iron phosphate hybrid battery. It claims it can improve security, low temperature performance, and also there's a whole section down in here talking again about the lithium iron phosphate hybrid battery. Now, while we can't get inside to see what's actually in here because I don't want to destroy this, I want to use it, we can get to the balance port so we can find out what this thing really is. Now, the owner's manual kind of changes its tune. It doesn't say anything about lithium iron phosphate. And when you go to the battery section, the cell chemistry just says lithium ion. But we can find out exactly what it is by checking the voltage on each cell, because a lithium iron phosphate battery has a lower voltage than just a regular 18650 lithium battery. And to figure that out, we're going to use the Wattage multimeter that one of you are going to win. Watch this. To install the batteries, we're going to be using the Wattage toolkit. Where is that Phillips? I just saw it here. This is actually a nice assortment. There it is. Links down below. Sponsored product. Oh, it's magnetized. Isn't that neat? Okay. Even comes with the batteries. Kendalls, I'm sure those are fabulous. Still has the brass insert for the screw there. Sure, that would make some bloke excited to see. Bob's your uncle. All right, let's find the voltage DC. Is that DC right there? I've never used this meter before, so we're figuring it out together. Oh, we got the little LEDs blinking there to tell me which banana jacks to use. Temperature probe. All right. Let's take a peek at these leads. Yeah, I don't think these leads are the ultra finey enough to get into the, I'm gonna back pin the balance plug there. So I'm gonna switch to my ultra fine meter leads to get this job done. Okay, so what we're doing here, if this is really a lithium iron phosphate battery, each cell is gonna be a maximum of 3.6. I believe that is the maximum highest you can go with lithium iron phosphate. Now, if this is just your run-of-the-mill lithium 18650s in here, then the maximum voltage is going to be 4.2. Now, if you remember when I first powered this thing on, the battery indicator said it was around 85% or 82% or something like that. So keep that in mind when looking at these numbers. Can you see the display better like that? All right, so if we are above 3.6, then right away we know this is definitely just a regular lithium battery that's in here. So let's take a peek here. Here is the first pin. This is ground, which should also be ground to here, to right to the battery. And so this should be cell 1, 0. Okay, so that's ground. So our first cell is 4 volts. This is not a lithium iron phosphate battery. Next one up should be 4 on top of that, so a total of 8. Okay, what do we got next one? 12. And then the full 5-cell battery voltage of 16. So this is a 5-cell. These are just going to be your regular 18650s in here. And since it can hold 2 wide and 4 high, let's see if I can get these stacked up. Yeah, you can see the individual bumps here of where each cell is sitting within that pack, and there's 12 bumps. So we're 4 times 2 times 12, so we're at 96 cells, which that's what makes these expensive. If I wanted to build this myself, I'd probably be a couple $100 in just the battery alone without the balance board or the inverter or any of the other parts. I think I just said 5-cell. I'm wrong. I'm an idiot. It's 4-cell. It's 4S. Here, let's just take a look right at the balance port I was going into. So first pin was ground. And then we've got the first cell, 4, 1. And then second cell, 8. That's cell number 2. 3 sets of cells is 12. And 4 set of cells is 16. So this is a 4S battery. And then the main battery power right off the main terminals, that is also going to be the 16.1 right now. When it's 100% charged, you'll be looking at 16.8 volts. Now, bear in mind, I'm not a battery expert. I could be wrong. Maybe when they say lithium iron phosphate hybrid, that means something that I don't know about. But just looking at the evidence here in front of me, this tells me it's just your regular lithium battery, just like the owner's manual states, not what the actual promotional ad states. That is not showing true for me here today. And this information could be important because if you ever plan on using the extended battery port, you don't want to be mixing battery chemistries. So if you took the Amazon ad at face value that it was lithium iron phosphate, now, and if you got a lithium iron phosphate extended battery, now your voltages are they're gonna be out of balance. They're not gonna match. You're gonna have a bad time. But they do make, this company makes its own extended battery. So if you're gonna go that route, you might want to get their battery because then you know it is gonna be compatible. But bear that in mind if you ever plan on building your own extended battery. All right, now let's take a look at the input section or the charge section. This is where if you were to charge it with solar panel or your car, it claims it's MPPT, which does look to be true. So here's where the input is, and we do have a inductor, not incredibly large inductor, but we do have an inductor with some, which I suppose are switching semiconductors, probably MOSFETs. So I do believe this is MPPT, which makes sense because it has a wide voltage range input. That just basically means whatever power you throw at it, it has a way of adjusting it to optimize it, to use whatever power you can give it to charge a battery within reason, within that 12 to 30 volts. And its input power, it doesn't say this in the Amazon ad, but it is maxed out at 100 watts, which is labeled in the owner's manual here. I saw it somewhere. Yeah, 100 watts max charging. Hold on, I think I saw DC input. Here's a DC input specs. Yeah, 12 to 30 volts and 100 watts max. And it is MPPT supported, which does look to be true. Now, also what this would mean is if you need an uninterrupted power supply, say if you have a device or a piece of equipment that you need to stay powered on during a power outage, theoretically this box should serve that purpose as long as you are under 100 watts of consumption. Now, theoretically, if you say you have like a fridge or a freezer that maybe you need to keep running in a power outage, if it draws more than 100 watts, that's okay because the pump is only running some of the time, but you probably got to figure it out to make sure you're consuming less than 100 watts continuous. Now, refrigerators and freezers are not continuously running. Or maybe, if you had a small computer or something that you needed to leave running during a power outage, this could be like a emergency backup supply that you can just run the AC charge going all the time and leave your device plugged in all the time, and it will just keep on going in a power outage. The USB power section is actually more impressive than the input power section. So we have another inductor, which is basically the same size as the one for the incoming power. We have a couple smaller inductors here too. I wonder if those have anything to do. No, the cigarette lighter is probably connected right to the main 16 volt power source. So all this stuff here is just for management of the USB port power. So it does claim 60 watts for USB-C. Got a couple of fast charge USB ports. I don't know if I'm going to check this, but that does look to be pretty beefy. So I can believe that would be a 60 watt power source. And before I put it back together, we'll take a quick peek at the 120 volt inverter output stage. Those are 40 and 30 MOSFETs, which I would assume would be in an H pattern configuration to make the AC. And these are good anywhere from 40 amps to over 100 amps, depending on what data sheet you look at. And now for the input lower voltage DC side of the inverter. This is the side that takes the battery voltage to run it up through the transformers to make the 120 volts. Anyways, these are a 250N04 MOSFET. They look to be good for about 200 amps each. Take a quick peek at them electrolytic capacitors. And they are, where did I see the brand? Yeah, right there. Sorry if I'm making you motion sickness here. Sine, that's what these are too, I believe. Yeah, there we go, right in there. Focus. Sine branded capacitors. Never heard of them, probably straight from China, but they gotta cut costs somewhere, right? The metal framing does continue all the way to the top to where the handle support is. Okay, we've got the unit back together. AC turned on. Let's take a peek at this sine wave. It's advertised as a pure sine wave, not modified. And that is actually a pretty dang nice looking sine wave. All right, before I put this thing through some tests, I'll give it a bit of a charge. And looks there, it's actually telling us the charge wattage, which is cool. There's nothing on the outputs. There's nothing pulling power. So this is the charge wattage. wattage. So we got 100 watts going into it right now. That's kind of a nice touch. I didn't expect it to show us the power going in. That's kind of cool. I like that. So I suppose in 1.3 hours we'll be at 100%. I think that's what it's trying to tell us. And to test the MPPT function of the charging input, I'm just running it at an automotive voltage, so 13.3 if you had this plugged into your cigarette lighter with the vehicle running. This is a 5 amp power supply, and this thing is pulling all of 5 amps. There's a little bit of wattage loss, but I'm using very thin wire, so I think that's where we're maybe losing a little bit of power. But anyways, it does seem to be a true MPPT. It's pulling everything it can from what I'm giving it. We're at 90%. I think that is good enough to do some real world load testing. Yes, it is time to see if this thing can really do what they say it can do. Got the Wagoner here. This thing has no trouble maxing out an outlet. I think it does over 1200 watts, no problem, maybe 1500. I don't know. You get the point. It pulls a heavy load. So let's turn on, I'm going to turn on the outlet. And here we have, we can keep an eye on the sine wave here, and we're going to keep an eye on the voltage here. We're going to see if things fall to pieces as soon as it's under a heavy load. So I'm going to turn on my heat gun. I'm going to turn the power down to start with. All right, so we're at 100-ish watts. Bounces between 100 and 120. The voltage is staying steady so far. We're at 111. That's looking good. Sine wave still looks like a sine wave. Let's bump up the power. Okay, we're now at 200-ish watts, 220, 200. Sine wave still looks like a sine wave. And we're still at 111 volts, so that hasn't budged at all yet. Let's bump it up again. We are now at half of its capacity, 300 watts. Everything's still looking good. Battery capacity is still at 90. Okay, maybe not, 89. Jump it up one more time. 400 watts. Okay, we did go down a little bit in voltage. We're still well within spec. Still holding in there. I like this meter. The backlight turns on as soon as it senses the voltage coming in. And it does show the 60 hertz at the same time as the voltage. So we're at 110, 60 hertz, true sine wave, and pulling 400 watts. Let's bump it up. Let's see if we can hit its max. 500. We're at 500 watts. So far the fans on the unit haven't kicked on yet. I'm sure they will soon. This thing is pumping out the heat. All right, so we're at 500. Time to kick it up again. Just at the 600, we're there. We are at its capacity, and it hasn't shut off yet or given us any trouble. So far, so good. It's time to put this in high mode. Now it's in high, so we're going to start to kick it up and see if we can exceed the 600. There we are, 620, 600s. The voltage is dipping a little bit. We're at 88 capacity. Let's kick it up. Ooh, we're almost at 800. You see that? We are well over its rated wattage. Voltage is dipping. Let's kick it up one more time. 700. I do notice it's shrinking. The voltage is going down. The sine wave is shrinking. I think what it's doing is it's regulating itself to its 600-ish wattage to conserve itself so it doesn't blow itself up. I'm going to put this all the way on max. Yeah, the voltage just dips. So it's in like a self-regulation, try not to kill itself mode. Put the power back down. Yeah, we're back at the 110 volts again. So it's protecting itself. But you saw it went 7, I think it even peaked at 8. Let's do that one more time. I'm going to crank it up. Ooh, 999! And it hasn't blown up, although the voltage is down to 75. All right, we'll give it a break. I'm going to let this cool down. Let's see how accurate the onboard watt meter is. I'm going to disconnect the charge. So now we see the discharge power instead of the, also if I turn on the outlet. Okay. Should get, there we go. Let me make sure this is in watt mode. Okay. And put this thing under load. There we go. Okay, let's let things settle out for a minute and see if these two watt meters agree with each other. So there does seem to be a little bit of a difference. Looks like the watt meter on the device is about, it's kind of bouncing around, so it's hard to say, but about 30 watts higher here than what's actually coming out of the outlet. We'll try some higher settings, kick it up a couple of notches, see what happens. Yeah, they're pretty close. This one seems to jump a little bit more on the high end, but you know, worst case, it looks like this is about 30 watts high. Try it for some higher wattages here. Yeah, it's consistently a little on the high side. Unless this would make sense if it's measuring the wattage loss from the inverter, because there's going to be some power loss at the inverter end, so this would be more representative of what the battery's seeing versus what the output of the inverter is seeing. And now to test the USB ports. The phone that I'm recording with right now that you're not able to see, unfortunately, is rapidly charging. So the USB-C output is working as it should. Let's check the standard USB rapid port. This is the blue port. No load, we're at 5.1. We'll put a 1 amp load on it. 0.95 amps at 4.96, so that looks good. I'm going to put this on high. And at 1.8 amps, the voltage is at 4.98. So that looks good. Let's check the next port up. Put it back on low. These are just the standard USB ports. 4.9 volts at 0.97 on the 1 amp setting, so that looks good. On high, 4.88 at 1.8 amps. The next port up should be exactly the same as one below. Should also be 1.8 amps. Yes, at 4.87 volts, so that looks good too. Let's check out this jump starter socket. Here's a pair of jumper cables from a generic little booster battery box. This particular model did not come with this, so if you want this, you have to make sure to order the right model. But we'll see if this generic one will work. It has the same plug. And I'm hooked up to the meter, so if I push this boost button, there we go, we got a green light, and we have battery voltage. So this could be a lifesaver if you're stranded, or at least it could save you from calling service, from getting a tow truck driver out to save your ass. But definitely a really cool feature to have that built into this. Here we moved to my kitchen. I'm running my refrigerator on it. When the pump is not running, when the compressor is not running, it shows the 57 hours. When the compressor is running, it goes down to like 4.2 hours. So it's probably going to average somewhere in the middle, I suppose, just depending on the duty cycle that the compressor is actually running. So let's just say, I think it'd be safe to say this could run it for a full day. And if this was on solar, that would be just enough time for the sun to come out to charge it back up. Although being that the input's only 100 watts, it might not pan out. But in a pinch, what I would do if I had a power outage for any length of time, this thing would be in my garage on my chest freezer, because I have a lot of meat out there, and the meat in my freezer is worth a lot more than the purchase price of this thing. So that could be a real lifesaver again there too. Time to summarize this portable power station. Let's see what they say we're going to get versus what we actually get. So to start off with the title, it starts off with the whole lithium iron phosphate, which we proved to not be true since we're at 4 volts per cell, and that is too high for lithium iron phosphate. And actually, in its own owner's manual, the first item on the FAQ is, what type of battery does the product use? This product uses a high quality lithium ion battery. So there, that solves that once and for all. 1800 watts, a turbo, I don't know, that's just an exaggeration. It ain't gonna hit any sort of reasonable 1800 watts. It kind of starts to puke out in the 700s. Pure sine wave, yes, that's true. It does have a nice clean sine wave. Solar generator, yes, it has a real MPPT input, which is great. It can charge on just about anything you can throw at it. All right, let's see, next on the list. Oh, the whole car jump starter stuff. Yes, it does have this jump start output, but you do need the appropriate adapter to use it. Some other selling points they use, the 584 watt hours. That's plausible based on the fact that it looks like the battery pack is holding 96 cells. So that is possible. Again, the A turbo power, 1800 watts. No, you're never going to hit a reasonable, usable 1800 watts out of this. But as far as the AC rated output, this might be a little confusing. It says 2 by 110 at 600, but it's just a total of 600. It's not 1200. It's just 600 real honest to God watts that it can actually hit, which is nice because usually when a Chinese product says 600 watts, what they really mean is 300 watts on a good day going downhill with the wind. So it's nice that this can not only hit its rated power, but exceed its rated power. So I'm very pleased about that. And again, here's just the DC input, 12 to 30 volts, 100 watts max. That is true. So even though it has sketchy 20 gauge aluminum wire going to the outlets, would I recommend this? It's a maybe. It did prove itself. It did hit over the 600 watts and it did not catch on fire. So the reality is it's 400 bucks just to buy the batteries, just the batteries. You're probably somewhere between $250 to $300 just for the cells. And then on top of that, if you tried to build a system like this, by the time you bought the inverter and the MPP charger, you would be over the 400, but it wouldn't be in a self-contained, well-organized, polished package. It would be a mess of wires and stuff. So this is a good solution. It is going to be handy to have around, whether you need to use it for camping or emergency car jumping a dead battery, or just having around in case you don't have good faith in your power grid. If you lose power for a night or something, you can keep things going. You have made it to the end of the video. Congratulations and thank you. To enter your chance to win the Coeit's Multimeter, down in the comments, just say Cabbage Patch. That's today's secret word, Cabbage Patch. Now you must be located within the lower 48 states, and you have to check your notifications when you get replies on comments, because I will reply to the winner. And if you miss it, you just have a day to reply back to me. So one day after this video goes live, I'll randomly pick one comment, and you have 1 day to reply back to me. You're going to win both the multimeter and the wire strippers. And if you miss out, I will have links down below for these items, plus the screwdriver kit too, which is hiding over here. Let's take one more look at this guy here. This has a lot of nice bits in it, a lot of security bits and whatnot. This I'm keeping for myself. Sorry guys, but I'll have links down below for everything you see here. And I think that does it for today. The multimeter, if you miss out on winning it, it's only $47. And if you use coupon code JF10, you'll get 10% off of that. So if you're looking for a good multimeter that's under 50 bucks, this might be a winner. Thank you all very much, and we'll see you next time.